Afternoon. Did everybody have a great lunch, I hope? Yes. Welcome to Philadelphia. I'm actually from Philadelphia, although I don't live here now. And my name's Kipp Bradford. I've been making a lot of stuff for a long time. Can everyone hear? Is that better? Raise your hand in the back if you can hear what I'm saying. Awesome. So I'll try to speak in the microphone. I have manufactured a lot of products, and I've sent a lot of products to manufacture through other people, and I've prototyped a lot of products. I started life as a toy inventor, and invented somewhere upwards of 3,000 products where I built full working prototypes. Let's see, I'm getting a little bit of feedback. All right, we'll just deal with feedback. So I make stuff, and I'm a biomechanical engineer. The stuff that I make is strange, it's medical frequently, it's industrial, and from that I've gained a lot of lessons, a lot of experience, some nice lessons. Yep, I'm gonna do that, and we'll go back to presentation mode. I'm just gonna put my laptop down here. All right, so my presentation notes are on that computer, little technical stuff. I'm just going to ignore the presentation notes, so you're just going to get a little bit of off-the-cuff stories. In the world of gadgets in America, and in the rest of the world too, there's this beautiful vision, this dream that I'll have an idea, and I'm really passionate about that idea. And because I'm really excited about it, I'm gonna build it, and then everybody else is gonna like it, and I'm gonna sell a ton, and I'm gonna become a millionaire, and it's gonna be rainbows and unicorns. But as we see from a lot of situations, that is rarely the case. The lessons that people learn in that process can be painful at best, can be legally tragic at worst, and what I want to talk about is what are the steps that you can take? What are some core ideas that you can follow if you want to avoid the kind of failures that a lot of projects in the hardware world see, and avoid the great catastrophes of engineering and manufacturing stuff. And I'm going to start off with my conclusion, which is that great communication solves a ton of problems. Great communication, and I'm not talking about me talking to you, I'm talking about how do I get the idea in my head, out of my head, into a format that can go into your head so that we both understand the same thing. So this is a talk about communicating better. And my basic philosophy is open source is one of the base drivers of effective communication in hardware manufacturing. So one story I have to tell is about a little project I did for Google where in 2 weeks I designed, sourced, manufactured, programmed, and deployed 600 wireless environmental sensor motes. It's one thing to build one, which I did in my basement with tweezers and a toaster oven, some squeegee for solder paste. You're probably familiar with that process. It's another thing to build 600, where 2 of the resistors on the circuit board were improperly placed at 90 degrees to the orientation they're supposed to be placed at, despite the fact that I'd given very, very specific instructions to the manufacturer. Not only that, I gave them 2 prototype boards so they could look at that and compare it to what was coming off the production line. Yet, they still made a mistake. And that's typical. That's to be expected. What was really nice in this case is that I took that batch of 600 boards where we were assembling them and programming them at Google's headquarters up in Boston. I loaded them into my station wagon. I drove them back down to the manufacturer in Rhode Island, and I sat down with the pick-and-place operator and said, here's the board that I gave you, here are the schematics, here's the bill of materials, et cetera, and here's what you made. And with no argument whatsoever, in 15 minutes, he said, I'll fix it. 4 hours later, they had removed 1,200 resistors, rotated them 90 degrees, and replaced them on the board. I drove back up to Google, and we continued our all-night run of getting all these things programmed. So 600, it's a small number. It might be big for some of you. But what about 6,000? And what happens when the people who are doing the assembly, the people who are doing the production, are not just down the street, but they're around the world. They're time zones away. They speak a different language. They're completely divorced from the process and the mindset that created the product. They're following someone else's instructions. This is what happens. You have good ideas that turn into lawsuits when everything breaks. So, my basic tips for success come down to the open source hardware definition. I think this is a great framework to understand how it is that open source hardware makes manufacturing better. And the key is the modify and make. But I think there's something that I don't know I'd say is necessarily missing in the open source hardware definition, but we want to emphasize. And what I want to emphasize is the preferred format. What does it mean to have a preferred format? What is the preferred format? So I do a lot of my mechanical work with SolidWorks. It is not an open source piece of software. It's an expensive piece of software. But I use it because every single factory I've worked with uses it. So in this context, preferred is the tool that lets me communicate best with my factory. But I also want to communicate with my customers. So I'll take my SolidWorks files and I'll export them into every possible format. If I'm going to open source this, I want people to be able to go to my website and download this in the format of their choice so that they can actually effectively use my products. And they can remix my products. So it's one thing to take an Eagle file and put it up on my GitHub site, but I also take all the documentation, all the PDFs, every single way that I can effectively communicate that information. The more open, the more likely I am to avoid mistakes. Eagle is one of the languages that we use to share. That didn't come out at all, but I think the important key here is making everything accessible. Making everything accessible in all the different ways that somebody would want that information. Sharing it so it's easy to get at. If you bury the information down your website, nobody's going to be able to find it. That's important for manufacturing, but it's also important for your customers. People want to know when something breaks, how to fix it. People want to know how it goes together. So the same sorts of things that make open hardware good, where effectively sharing things with the community means having good documentation, clean files, also will save you from the kinds of problems that manufacturing face. But there are two other nice aspects about making your designs open before you go to manufacturing. One is that stuff that's unmanufacturable will get called out by the community. Inevitably, you'll have somebody, if you've built your product on top of open source development work, then somebody will say, we tried that, it didn't work. Or, I know the process that you're going to use, and that's completely unmanufacturable using that process. Another nice thing is you get the design bullshit call out. So when you do something that's just poor design or poorly thought out design, your community will call you and say, hey, you know, that's a really bad idea. That's never going to pan out. Your manufacturers have the transparency to see the thought processes that went into designing your product. And they can call out and say, do you really want it that way? Because we have manufactured 1,000 products like yours, and you're an outlier. There has to be a good reason that you've chosen to make your design strange, because we've never seen that before. Why are you doing that? And you might say, oh, that was a legitimate error. I didn't know I wasn't supposed to. Or you might have a good reason to, and then your manufacturer's not going to second guess you. If this is the wrong audience to ask this question, but some of you might fear that, well, if I make my product open, it's going to get ripped off. My counter to that is my last trip to Shenzhen, where which of those Apple stores is the real Apple store? The answer, none of them. They might all look like the real Apple Store. They have people wearing Apple t-shirts in them, all of the products. It looks like an exact Manhattan Apple Store picked up and placed in Shenzhen. But when I went to take a picture of it, security guards came rushing out and practically tackled me. So this is me running away from the security guards trying to take pictures of the 3 Apple stores. If the company that has a multi-billion-dollar team of lawyers, one of the most aggressively protected patent portfolio in the world, can't keep clones from happening, well, you have no hope in doing that either. So you might as well make things easier on yourself, open source the products that you're manufacturing for the consumer market, and share and grow the community and support innovation. So that's it for me. Thank you very much.